Hi, my name is Chris Chapman, and I'm the founder of Systems Thinking TO, a regular monthly meetup in Toronto, Ontario, Canada, dedicated to the improvement of organizations through the exploration of systems thinking theories, practices, and techniques. We have a three-part mandate: to educate, share knowledge, and reach out to others who are practicing systems thinking in their work. In support of this mandate, we often host guest speakers at our meetups and sponsor workshops where attendees can gain practical knowledge on how to apply systems thinking techniques at their organization. With me today is internationally recognized lean consultant, blogger, and published author Mark Graban, who will be bringing his workshop to Toronto this March 26th based on his latest book, Measures of Success. The book is available now on Amazon Kindle and Apple Books and will soon be available in print. Sure. Welcome, Mark.
Thanks, Chris. Here's an early, what they call a galley copy of the book. It will soon be a physical thing, but thanks for having me here. And I always cringe. I laugh when I hear internationally recognized. Like literally a couple months ago, I was in Regina, Saskatchewan, and someone came up and said, "Hey, you're Mark Graban, right?" So I am. It's not just an expression. I was in of all places, Regina. It was someone I had met previously at a conference.
That's fantastic. And there was a time where you and I were on planes passing each other out of Winnipeg, I recall, a few years ago. So
yeah. I do get to Canada quite often. I always enjoy it.
That's excellent. So for the benefit of those who may not know you, could you give us a brief summary of what you specialize in and how you integrate systems thinking into the work you do for your customers?
Sure. I mean, I think I most often nowadays get described as a lean healthcare person. I've focused pretty heavily in healthcare since 2005, but I started my career in manufacturing. I was really fortunate to have exposure not just to Toyota and lean manufacturing concepts, but I got exposed to the work of W. Edwards Deming really before that was a great foundation for then learning lean and the Toyota production system, because Toyota executives, even to this day, 25 years after Dr. Deming passed away, they still give a lot of credit to Dr. Deming. So that was some of my introduction, if you will, to systems thinking. I had a chance to formally study system dynamics at MIT. And I think learning how to look systemically or think systemically or to understand some of the reactions that you see in complex systems, it's easier said than done to think systemically. But I think there's some practical things that we do in healthcare, for example, trying to help break down silos between departments, looking at patient flow through a value stream and across organizations. That's a system. And trying to look at the way systems behave and realizing that systems produce results. The design and execution of the system influences performance much more greatly than the effort or skill of individuals. What's the expression? The system is perfectly designed to get the results it gets and also recognizing, as we'll talk about here, there is going to be variation in those results. The same system on different days or different weeks or different months will not exactly give the same results. That's a fact of life. And I think that's a lesson that comes from Deming and Donald Wheeler and others I've been fortunate to learn from.
Absolutely. And that's something that's going to resonate very strongly with our membership and our attendees. This is something we speak about just about at every meetup. So your upcoming Toronto workshop is going to be focusing on teaching attendees how to create process behavior charts. What is a process behavior chart and how is it used?
Yeah, so I mean, we'll just go ahead and look at an example. We have an opportunity to sort of visualize this a little bit. A process behavior chart, it's a combination of two charts. I'm going to just show here what's called an X chart. This is the plot of the data itself. So a process behavior chart is a specialized run chart. So we plot the data, we calculate from a baseline period like we see here an average, that's the line in the green. And then we also calculate what are called lower and upper natural process limits. So those are the red lines there. So as it says on the screen here, this is, statistically speaking, what we would call a predictable system. This is a chart showing the number of weekly falls at a hospital in England. So those are actually weekly increments across the x-axis. And the nurse executive that I was working with, she was in one of my workshops a couple years ago. She had a mandate, I think it was something like reducing falls by 30%, kind of a national target, an admirable goal. So there are all sorts of things, unfortunately, that organizations could do. You might cherry pick 2 data points. You know, there's a data point that says 30, there's another one later on of maybe 16 falls. We could claim, oh, look, we reduced falls by 50%. That's probably not accurate. You know, we could draw a linear trend line, which implies, in this case here, that falls are going down and will continue to go down if we do nothing. And that's probably unrealistic. We tend to have a stable system in a hospital or other workplaces. So even just from this view, we would call this a predictable system because the metric is just fluctuating basically randomly around that average. And drawing in the average emphasizes that roughly, you know, we're going to have half the data points that are above average and half the data points are below. It's not always exactly half, but we learned there's really not a lot of point in reacting to every up and down. Why did falls drop last week? In a predictable system, the system is delivering variable results. There was nothing different that's worth investigating or explaining or reacting to, but people end up wasting a lot of time in organizations chasing, if you will, the noise in a metric, reacting to every up and down. You know, you need to explain every below average data point. Like that's stuff that gets in the way of real systems improvement. So here's an example of a baseline period that was all noise. And the thing about a predictable system is that the process behavior chart methodology allows us to predict that going forward, unless we can improve the system, it's likely to continue fluctuating around this average, and anywhere between about 8 and 33 falls would be, any single data point in that range would possibly be randomly occurring. But as we add more data points over time, if you can show the next example, you can see, so, you know, linear trend line analysis might say, well, it looks like it's going down, but again, I think the fault of a linear trend line is that it applies, it's going to continue going down. Where here's an example of finding not more noise, but finding a couple of different types of what we could call signals in the chart. Signals are worth understanding. They are worth possibly reacting to, because it's a statistical signal that says the system has changed in a significant and or sustained way. So the first signal, those 8, actually it's 9 consecutive data points below the baseline average. So probabilistically speaking, that's very unlikely to be randomly occurring. We could feel confident that we either made a change that's having a positive effect on the metric, or something happened and we better go investigate and discover what that is. So that would be an indication, 8 consecutive data points or more below the average. And then there was a data point just barely back above the average. But then you can see following that is a longer run of consecutive data points below the average. So I'd feel confident and say, well, we've made a step function improvement in the system and the metrics. There's an additional signal. You notice so September 8th, 2016, there was a data point there below that calculated lower process limits. So that in and of itself would be a signal that the system has changed significantly. So there are certain rules and guidelines, statistically based, that would tell us, we don't have to guess, is that noise or is that a signal? So the last thing to look at on this chart is, now I've sort of represented, you know, that you can see the first version of the system was fluctuating around this average of about 20, and then it apparently dropped and is now fluctuating around an average of about 14. So instead of looking at just 2 data points, I would feel confident saying the average number of falls fell from 20 to 15. That's a good start. We could continue improving the system and hope to see continued step function decreases. But as time went on, unfortunately, we see now more of a negative signal, if you can click on that. So here we have 1, 2, 3, 4, 5, 6, 7, 8 consecutive data points above that average. This to me would be cause for concern. Not either of those individual data points, but the fact that we have 8 consecutive data points above that newly established average, that would make me think and question, has the system degraded to what it used to be in the first phase of the chart? Or so is there a sustainment issue, or was there some additional change, that a new problem that led to falls going back up? So when we use process behavior charts in a nutshell, and this is the subtitle of the book here, when we react less, we can lead better and we can improve more. When we repurpose the time that's wasted explaining all of the noise and actually step back and more systematically try to improve the system by using A3 problem solving or your favorite systems improvement approach, basically, like react less. And that doesn't mean just sit back and watch it fluctuate. It means improve the system. And in my experience, those reactive questions don't really help us improve the system. We need a different approach in those cases.
So I'm sure a question that some folks are going to have looking at this data presented over time is, how much data do you need to collect to make representative decisions based on this process?
Yeah, I mean, ideal is to have a baseline of 15 to 20 data points. Someone's got monthly data, give me a year's worth of monthly data. 12 data points is pretty a good start. Don Wheeler teaches that you can start with as few as 4 data points. The problem is because there's fewer data points, the limits are a little bit less reliable. You might more likely have a false signal, or you might miss a signal. So as you add more data points to the baseline, when you get to about 15 or 20, there's diminishing returns to having more data points in the baseline. So I think if you've only got 4 or 6 or 8 data points, using a process behavior chart is still better than comparing 2 data points, or using, we'll explore this more in the workshop, cases where linear trend lines, I think, are just kind of dubious. That would be my answers. You do need to have some baseline data. I'm always skeptical when I see people present improvement where there's like a single data point representing the before and then a bunch of data points showing the after. Like, I don't know in that before, because again, there's always going to be variation in the metric. Is that single data point is that essentially cherry picking the data of the old system, whether that was intentional or not?
Cool. So given this, who should attend your workshop and why?
So in the past, when I've taught this, there have been more senior leaders or business owners or managers. There have also been process improvement specialists, so they might call themselves lean facilitators. I've had some Six Sigma master black belts take my workshop, and it's always a little intimidating because I know this process behavior chart methodology really well. The Six Sigma master black belts have a broader statistical knowledge, and I'm always afraid that someone's going to kind of get into like a match of wits about that way. But I've gotten feedback though from the Six Sigma folks to say that this methodology, it's clear, it's valid, as opposed to all the different types of control charts that are generally taught in Six Sigma. That some of the Six Sigma black belts have said, what, this is a methodology I could actually go teach and probably have a better chance of it being accepted, because my executives' eyes glaze over when I start talking about the different types of control charts, that term, or process behavior charts. Those people have attended workshops. I mean, these methods apply to any organization with metrics. I've taught this and coached people on this for healthcare, manufacturing, software companies, services. It really has broad applicability. So, to the answer of why attend, you'll learn some very practical tools, but I think you'll also learn some of the mindsets. There are a number of exercises that we do in the class. We'll do Dr. Deming's famed red bead experiment, which is a really helpful way to start understanding and building intuition about variation in a system. We'll learn how to make process behavior charts and how to use those with data in the real world, of learning when to react and when to step back and improve more systematically.
Excellent. So at the risk of sounding a bit redundant, what can attendees to the workshop expect to learn besides the process behavior charting methodology and process? And what can they start to apply the next day or the following Monday when they get back to the office?
So like you said, like we talked about process behavior charts, sometimes a baby step to getting there is just converting from tables of numbers and doing even just a simple run chart provides such a better visualization than lists of numbers or what people sometimes call bowling charts. We'll talk about some of the problems with kind of red-green analysis and why comparing a metric to a target isn't enough. We need to look and see if we're improving, and if not, how do we need to improve? So we'll talk about that. And in learning process behavior charts, I always encourage people to bring a data set from their own real workplace. And we spend time actually creating process behavior charts. So we can just use Excel or Google Sheets or whatever spreadsheet you have, and then have people present those spreadsheets from those process behavior charts to the class. What do you see? What are the insights you're getting out of the chart? What are you going to do differently when you go back to work? I'll coach people on that. Chris, I'll probably rely on you to also help coach people a little bit. And the most exciting thing is the follow-up emails from people who have gone back to their organizations and introduced these charts and learned from it, and have found value in it. It's like I like to say, I mean, it's arithmetic. It's not calculus. It's really not that difficult of a method to understand or to put into practice. It's really I found quite useful.
So you've conducted this workshop about 10 times now. What have you observed and learned about who attends and why they come?
Yeah, I mean, I think people. It's always fun to see the light bulb moments, and when people start questioning the way they've always done it. I can't stand there and tell people. I may run the risk of telling people the way you're doing it now is bad, because that makes people just sort of double back on, well, this is how I was taught. This is how we've done it. But at the same time, I think the people coming to the class generally are choosing to be there as opposed to being sent there. So it's a biased sample of people who have some inkling that something about the way we're managing now isn't working, and there's got to be a better way, or they're open to a better way. So again, the red bead experiment is kind of a fun yet challenging way for people to reflect on some of their current management practices, not just how do we visualize data. And if they weren't already convinced that there's opportunities to, again, I'll come back to the book subtitle, react less, lead better, improve more. I think they leave the workshop feeling like that's definitely the case.
Excellent. Well, thanks, Mark. So your workshop is set for March 26th, 2019 here in Toronto, Ontario. Where can people go to learn more about the workshop and register if they're interested?
Yeah, so if people go to, as you see on screen here, markgraban.com/Toronto workshop, that will forward to the event page and the ticketing engine, and that'll have more detail. If people have questions, I'm pretty easy to find online. mark@markgraban.com is my email. You can find me on Twitter or LinkedIn, or I had somebody send me an Instagram message, which is probably the least reliable way to contact me because I don't use Instagram very much. But if you've got questions about the workshop, it's designed in terms of like prerequisites. Like I would hope that people have familiarity with using spreadsheets. I mean, I walk people through a lot of this very much step by step. And usually people pair off if someone's an Excel expert and someone is not as comfortable with Excel. But really, there's no prerequisites. You don't need to be a something or other belt. We'll take you through it, and you'll go home with some methods that you can use.
Oh, fantastic. So thanks again, Mark. So before we go, thank you. Before we go, a reminder that Mark will also be speaking at our March 27th meetup of Systems Thinking TO. You can learn more about this at the URL on the screen, meetup.com/systemsthinkingto. I'm looking forward to seeing all of you at the workshop and the upcoming meetup this March. Thanks again, Mark.
Okay, thank you. And I'm looking forward to being up there in Toronto. Thanks a lot.